For your test, what I'm going to do, I don't have a practice test for you because I messed up the print shop order and ordered double algebra and no geometry. So, oops. So what I'm going to do is I'm going to go through and show you like the types of problems that are on the test, not the exact problem that is on the test, and then after we go through them, you can ask questions, or if you want to see more of a certain type, we can do that as well. Okay, so the first kind of problem that you might find on the test is I might give you a shape. Like this. And then I might ask you questions about the shape. Okay, I'm giving you a shape and I'm going to ask you questions about it. All right, so let's say so I might say, okay, A, B, and C are what? And you give some options. Are they collinear, coplanar? Are they on line BC? Do they contain point D? So we look at points A, B, and C. Are they collinear? No, right, because they're not on a line. And they're not on line BCA is not on BC, correct? Okay. So we're down to coplanar or contains D. Coplanar. Okay. And then I might say something else about this shape. I might ask you which segments are congruent. What's a rectangle? What do we know about rectangles? They're parallel opposite sides, but what else? They're also the same length, right? Opposite sides. So I could say that BC is congruent to AD, and AB is congruent to CD. And then I can come in here like this, and I can add that guy, and I can tell you that E is a midpoint. And then I can say find X. Of course, I'll have to give you some more information. But what do I know about these two if E is a midpoint? No, if I tell you that this part is 3x minus 7 and this part is 11, what do I know about those two things if E is a midpoint? They're equal, right? Because midpoint's halfway, so to find X, I would set those equal to each other. What kind of angles are these? Which one? Right. Any questions about that? Attachment. With the law of syllogism, we had if P, then Q, and then we had if Q, then R. And so what we would do is we would take out Q. Get rid of Q. Yeah, and then we go straight from this to if P, then R. take out the middle guy. That's syllogism. So the conclusion, this is the conclusion. Okay. And the only way you can get a conclusion is if it's PQ and then QR. So that Q has to be in these positions. Okay, if Q is not in the right position, so if it's like PQ, RQ or something, so you don't have the same thing here and here, you can't come to a conclusion. And I'll do an example. So let's say if I go to work, then I get money. If I get money, then I buy chocolate.
Did you bring the applesauce and save it? It's okay, I forgot to save it.
If I go to work and I get money, if I get money, then I buy chocolate. So my conclusion is if I go to work, then I buy chocolate. And it has to be in that exact order to come up to this conclusion, because I can take out this part and go straight from if I go to work, then I buy chocolate. So far, okay? If you recall, was if P, then Q, and then we said P. And then you conclude Q. So for this particular one, you have to say first, second, first, and then you can conclude the second. If it does not go in the right order, so first, second, first, so if it's like first, second, second, there's no conclusion. An example would be, if I go to the beach, I get dirt in my shoes. I go to the beach. So the conclusion is I have dirt in my shoes, or sand in my shoes, because I went to the beach. However, if I say if I go to the beach, I'll get sand in my shoes, I have sand in my shoes. It doesn't mean I went to the beach. I could have sand in my shoes from my yard or the park, or maybe somebody else just decided to dump sand in my shoes because they're mean. I mean, we don't know, right? It doesn't mean I was at the beach. It just means I have sand in my shoes, so I can't come up with a valid conclusion unless I say I went to the beach. And then the conclusion is, okay, that must mean you have sand in your shoes. So with the work chocolate example, if I go to work, I will buy chocolate. I went to work. You can conclude I bought chocolate. Or if I say, if I go to work, I'll buy chocolate, I bought chocolate. It doesn't really mean I went to work. It could be Saturday. Questions on that at all? Also, Godiva has the chocolate covered strawberries in the market.
No.
I was there yesterday. All right, so we have the transversals, parallel lines. So let's say got a couple different relationships that I'm going to talk about here. Okay, so this will be line M and this will be line N. And we will indicate that line M and N are parallel, even though they're not actually straight lines because I can't draw a straight line to save my life. Okay. And then we'll come in and transverse M and N with T. I'll do another segment here, S, and we'll say that T and S are parallel. And then I'm going to come in with another line, Q. And Q's not parallel to anybody. Okay? We have several different things that can be happening. So I'm going to number all my angles really quickly. Okay. Angle relationships. T and Q are not parallel. But angle 1 and angle 16 would still be alternate exterior with a transversal of N. Okay? They just wouldn't be congruent because we only get congruency with parallel. So if you have a drawing like this, we're going to look at our sets of parallel lines. I have M and N are parallel. So since M and N are parallel, these groups of angles 1 through 4 and 5 through 8 have a relationship of congruence because M and N are parallel. T would be their transversal. So 1 and 4 are the same, 5 and 8 are the same. All of those are the same as each other. And then two and 3 and 6 and 7 are all going to be the same. Now I can look over here at S and T. S and T are parallel with M as their transversal. So when this happens, my parallel pattern continues. So 6 and 11 and 10 and 7 and 9 and 12. So if you have two sets of parallel lines, your pattern will continue. But if you have two parallel lines here, M and N, and then T and Q that are not parallel, they're two separate sets of congruent angles. So over here on Q, I'll have 13, 16, 17, and 20 that will all be the same. And 14, 15, 18, and 19 that will all be the same. But they don't have any relationship as far as their angle measures with the ones that are hanging out on T. Questions about that? Again, something like that. Good. All right, so if I ask you, what kind of angles are 13 and 12? Okay, how about 10 and 14? They're in the same corner, right? The same, so corresponding. Um, 5 and 16? which transversal forms angles 4 and 11. So which line is the transversal? We're looking for 11. Yeah, line A. So these are okay? What if I told you that these lines are parallel and so are these? And so I said, I told you to find x. 30, right? So I'll solve that by subtracting 2 extra sides. I'm giving you the distance and I'm asking you to find the missing coordinate for a point. So I give you one point is 10x and the other point is 4, 5. Actually, I should probably make that 10y. That makes more sense. Okay, so you have to use the distance formula. Okay, so your distance formula, and you plug in the numbers that you have. So if this is x1, y1, then this would be x2, y2. So I have the distance is 10. And x1 is 10 minus x2, which is 4. And y1 is y minus y2, which is 5. Okay. Now I usually go ahead and get rid of the square root first. So what I want to do that's weird, is I'm going to square both sides. And I square both sides to cancel out the square root. And so I get 10 is equal to 6 squared plus y minus 5 squared.
100.
Yes, it is. It's 100. Thank you. So I get 100 is equal to 36 plus y minus 5 squared. And then I'm going to subtract 36 from both sides. And I'm going to get 64 is equal to y minus 5 squared. And I'm going to take the square root of both sides. Because the square roots cancel out the square roots. And we're going to get 8 is equal to y minus 5. And I'll add 5 to both sides. And I'll get 13 is that y coordinate that's missing.